हेलो बच्चों, हाउ आर यू? वेलकम टू साई academy. Today in this video lecture you will be learning about how to solve the trigonometrical identities part 2. In the previous series of this lecture I have solved some problems based on the trigonometrical identities. Today we will solve more problems. So let's start. Prove that 1 by sec A plus tan A plus 1 by sec A minus tan A equals to 2 sec A. So let us prove this. So proof is, let LHS is given equals to 1 by sec A plus tan A plus 1 by sec A minus tan A. That may be written as 1 by 1 by cos of A plus sin A divided by cos A plus 1 by 1 by cos A minus sin A by cos A, which is further can be written as cos of A divided by 1 plus sin A plus cos of A divided by 1 minus sin A. So बच्चों, here I have taken the LCM and then solved this fraction. So I got this value and this value. Okay. Now this further can be solved as taking the LCM of 1 plus sin A and 1 minus sin A as 1 minus sin square A. So this is nothing but the product of this and this. So after solving this fraction we get 1 minus sin A into cos of A plus 1 plus sin A into cos of A, which further can be written as equal to cos of A can be common out. So 1 minus sin A plus 1 plus sin A divided by 1 minus cos sin square A is equal to cos square A. That means this will cancel. So we'll get 2 cos of A divided by cos square A, which reduces to 2 by cos A, and it gives 2 sec A, which equals to RHS. Hence we proved the problem. Now further question number 4, we have to prove that sine of A divided by 1 plus cos A equals to 1 minus cos A divided by sin A. So we have to prove this. How can you prove? So let's start. So proof is like this. Let LHS equals to sine of A by 1 plus cos A. Now multiply this with the conjugate of 1 plus cos A in the numerator and denominator. So you will get sin A by 1 plus cos A into 1 minus cos A divided by 1 minus cos A, which further can be written as LHS equals to 1 minus cos of A into sin A, and the denominator will become 1 minus cos square A. As we as you can see that 1 plus cos A into 1 minus cos A will become equals to 1 minus cos square A. So which further gives 1 minus cos A into sin A divided by sin square A. That means we get 1 minus cos A divided by sin A, that is equal to the RHS. So we solve the problem. Now question number 4 2. So we have to prove that 1 minus tan square A divided by cot square A minus 1 equals to tan square A. So how can we solve this? So let's see. Proof. So proof can be done like this. Let LHS equals to 1 minus tan square A divided by cot square A minus 1, which can further be written as LHS equals to 1 minus tan square can be written as sin square A by cos square A divided by cot square A can be written as cos square A by sin square A minus 1. So we got this. Now after simplifying this, we get cos square A minus sin square A divided by cos square A minus sin square A into sin square A by cos square A. So how this come? This comes because we have solved the numerator and denominator separately. So this gives cos square A minus sin square A divided by cos square A, and this gives cos square A minus sin square A divided by sin square A. So further this gives cos square A minus sin square A divided by cos square A minus sin square A, and after this will be like this. So I hope you got this point. Now this can be written as, this will cancel out. This becomes sin square A by cos square A, that is equal to tan square A, and this is equal to RHS. Now next problem, we have to prove that sine of A divided by 1 plus cos A equals to cosec A minus cot of A. So we have to prove this identity. So let LHS equals to left hand side equals to sin A divided by 1 plus cos of A. Now further we will multiply this fraction by the conjugate of 1 plus cos A in the numerator and denominator. After that we will have LHS is equal to sin A divided by 1 plus cos of A into 1 minus cos A divided by 1 minus cos A. That is equal to sin A into 1 minus cos A divided by 1 minus cos square A. So this and this after multiplication gives 1 minus cos square A, which further gives sin A into 1 minus cos A divided by sin square A, that is equal to 1 minus cos of A divided by sin A. As this sin and this one sin A will be cancelled out, so finally we will have 1 by sin A minus cos of A divided by sin of A, which gives cosec A minus cot A, and that is equal to the RHS. Hence we proved the problem. Next. So in problem 5a, we have to prove that sec A minus 1 divided by sec A plus 1 equals to 1 minus cos of A divided by 1 plus cos of A. So let us prove this. LHS is given equals to sec A minus 1 divided by sec A plus 1, that can simply be written as 1 by cos of A minus 1 divided by 1 by cos of A plus 1, that is equal to 1 minus cos A divided by cos of A and 1 plus cos A divided by cos of A, which gives 1 minus cos of A divided by 1 plus cos of A, that is equal to RHS. Hence the problem is solved. Now question number 5, second part, 5.2. So we have to prove that tan square theta divided by sec theta minus 1 whole square equals to 1 plus cos theta divided by 1 minus cos theta. So बच्चों, we have to prove that this identity. Now let us prove. So let us assume that LHS is equal to tan square theta by sec theta minus 1 whole square. That can be written as tan square theta in terms of sin square theta divided by cos square theta. Further, sec theta can be written by 1 by cos theta minus 1 whole square, which further gives sin square theta by cos square theta into cos square theta by 1 minus cos theta whole square. So we have now sin square theta divided by 1 minus cos theta whole square. Sin square theta further can be written as 1 minus cos square theta divided by 1 minus cos theta whole square. We know that 1 minus cos square theta can be written as 1 minus cos theta into 1 plus cos theta, and whole is divided by 1 plus cos theta, sorry, 1 minus cos theta, 1 minus cos theta whole square. That means we have now 1 plus cos theta divided by 1 minus cos theta, that is equal to RHS. So we have next problem 5.3. So in this we have to prove that 1 plus tan a whole square plus 1 minus tan a whole square equals to 2 sec square a. So let us solve this. LHS equal to 1 plus tan a whole square plus 1 minus tan a whole square, that equals to 1 plus sin a by cos a whole square plus 1 minus sin a by cos a whole square. Is further after simplification can be written as cos a plus sin a divided by cos a whole square plus cos a minus sin a by cos a whole square is further can be written as LHS equals to 1 by cos square. A can be taken as a common out. Now we have cos a plus sin a whole square plus cos a minus sin a whole square, which after simplification we get 1 by cos square a into expanding this cos a plus sin a whole square, we have cos square a plus sin square a plus 2 cos a sin a, and simplifying this, expanding this, cos a minus sin a whole square gives cos a gives cos a whole square plus sin square a plus minus 2 cos a sin a. So we see that this and this will cancel out, and we have now 1 by cos square a into cos square a plus sin square a plus cos square a plus sin square A. That means this will be equal to 1 and this will also be equal to 1. So we have 1 by cos square A into 1 plus 1, that is equal to 2 by cos square A, which gives 2 sec square A equals to RHS. Hence we proved this problem. Now in 5.4 we have to prove that sec square A plus cosec square A equals to the product of sec square A into cosec square A. So here you can see this is the sum of the sec square A plus cosec square A, and in the RHS it is the product of the two. We have to prove this. Let us prove. So proof is given as let LHS equals to sec square A plus cosec square A, that can be written as 1 by cos square A plus 1 by sin square A. After simplification, we can write as LCM is sin square A into cos square A. So this gives sin square A plus cos square A, which is nothing but this will give equals to 1. So we will have 1 by sin square A into cos square A, that gives sec square A into cosec square A. That means we have LHS equals to RHS. Hence the problem is proved. So friends, we solved many problems here. So stay tuned throughout whole of the videos and press the bell icon for getting the notification of the upcoming videos, because I am going to publish series of lectures based on this trigonometry topic. Okay, thank you.